See, if you observe how the industry is using NAND gate, so that is what I'm calling it as NAND realization. Okay, realization means it's a technical term. Realization means NAND gate implementation only. Okay, guys. So NAND gate means what? Your result finally should be A into B complement to B complement. Guys, we have various kind of like gates are there. One is not inverter is there. Not inverter is there. What is the property of not inverter? If you are going to give A as input, you need to produce the output as A complement. A complement. For that, the basic symbol we have gone through is like this. Right? A, your output will be A complement. Okay, good. Now, can we implement this NOT gate with respect to NAND gate? Yes. Right. So I think while discussing the previous class itself, I have shown this one. Right. See, if you are going to have the like NOT gate, try to observe. If you are going to have NAND gate look like this. Look like this, right? So NAND gate symbol is like this only, right? Yes, NAND gate, right? Try to give. I am trying to give two inputs as A and A. A and A. What is A and A? A that will be complemented to again A complement only, meaning that it will be acted as NOT gate, right? So I am trying to modify this structure like this, right? I am going to give A as input. I am going to go produce as A complement. See, this is the NOT gate representation in terms of NAND gate. Okay, fine. So if you try to take out the next kind of gate, AND gate. So AND gate means what? If I am going to give A and B as input, I need to get the AB. I need to get the AB, right? Truth table has to be satisfied, right? See, guys. So for our simplicity, how can we do this in terms of NAND gates, right? So NAND gates means what? In terms of complements, it is available. So what I will do now? I will simply perform complement over complement. So complement cancel. Again, you are going to get the same thing, right? Can I do AB complement? Can I do AB complement? Yes. If I am going to have the two inputs AB, if I made like this, the result will be AB complement. For this complement, can we get the complement? Can we get the complement, right? How can we get the complement using NAND gate? This circuit, right? Then you are going to get AB. So this is the circuit you are going to use in order to replace AND gate with NAND gate. NAND gate. Okay. Fine. Similarly, we have OR gate is there, right? So OR gate means what? A plus B. How can we get the NAND gate relation? Because you have to define in terms of everything in the form of complements. But try to do that, right? I will try to make the complement of this A plus B whole complement, whole complement. So again, you are going to get A plus B only, right? This I can be write it as A complement dot B complement whole complement, right? Now, if I am going to have the input like this, if I am going to have the input A, from that input A, can I get A complement? Yes, first done. Now, if I am going to have input B, can I get B complement? Yes, I done. From this, again whole complement. So, simply you have to use again NAND gate. Now, this is A plus B. So, this is the circuit you are going to use for OR gate in terms of NAND gate, right? Let us take one more uh, XOR gate, right? XOR gate means what? It's like think A bar B plus B bar A bar B plus B bar A, right? So here, for example, if I try to construct, uh, the simple thing, like let me take A as input, I am going to get A bar as output, right? that I am going to give input as to the AND gate, right? A bar B. Okay. Similarly, B bar A, B bar A, right? So this is A you are going to get, and you require B bar, right? So I am going to make it complement B bar A. So finally you are going to get B bar A, and for this both I am going to construct OR operator. So your result is going to be A XOR B. Okay, fine. So as I said, so industry has to do what? This one OR gate is required, two AND gates are required, one OR gate is required. This is not. One OR gate is required. That is what they try to do, right? But thing is, as the requirement is changing, they have to like for example, they have implemented 1,000 AND gates, 1,000 OR gates, and 1,000 NOT gates. We don't know which one requires how many exactly. That's the reason. If you are going to implement all the things in one kind of a gate, then the company will produce only NAND gates 3,000 instead of producing one some or some and some not, like that. They will produce all NAND gates, so there is no loss, there is no problem for them, right? That's the thing, right? Okay, fine. Now we'll try to represent this XOR gate in terms of NAND gate. How to do that, we'll see. Okay guys, here the expression like A bar B plus B bar A, right? So as I am trying to write all in its complement form, I'm trying to write all in its complement form, I am trying to get with the complemented data, right? So A bar B, B bar A, I will try to add A bar. Is there any problem? A bar is 0, B bar also 0, right? Okay. Now I will try to take out the common B common from the first and last midterms. Then you are going to get A bar plus B bar. From the between second and third, I am going to take out the A as common. You are going to get B bar plus A bar. A bar. Okay, fine. Now can I write like this? Uh, this is like De Morgan's law, right? So De Morgan's law, if you are saying that A bar plus B bar, can I write like AB whole bar plus AB whole bar or BA whole bar? Both are same, right? AB whole bar. Now, see guys, try to observe why I have written, because now this one I can represent in the form of complement representation, like NAND representation. That's why I come across this particular procedure, right? So I will do like one kind of representation, like if I am going to have AB as input, I can get AB complement. That's why I came up to this procedure. Okay, one is done. But what about the remaining A and B? So that reason, what you can do now, you can just make it double complement. Double complement, right? So if you are going double complement, again you are going to get the same expression. Now try to solve this again. So main complement is as there, right? Inner complement I am trying to distribute over this data. Then you are going to get B into AB bar whole bar dot A into AB bar whole bar, right? So guys, try to observe now. AB bar is one component. AB bar is requires one NAND gate, and these two requires one NAND gate, and the whole complement requires one NAND gate. That's it, right? This is the simple way. So what you can do now, try to take out two inputs A, B. Those two inputs I am trying to give A, B. First I am going to get AB complement. AB complement, right? Is this AB complement done? Yes. So your output will be AB complement. AB complement, and this AB complement I need to give it to what? B, or let me do with A. First I will try to do this particular procedure. I will try to do it with A, right? If I am going to go with A into AB complement we got. For that, sorry, A into AB complement we got. For that I am going to have once again complement. Now this one act as this one. Similarly, B into AB complement we got. For that whole complement is NAND gate. This expression also done. This expression also done. For that you need to have again whole complement. Complement you are going to write, right? You know. That's it. This is the corresponding XOR gate. XOR gate for XOR gate in terms of NAND gate. In terms of NAND gate, right? If you want, you can able to solve this expression again, right? So here you are going to get uh, A B bar, A B bar. Okay. Here assuming that this has X and this has Y, at X location you are going to get A into AB bar whole bar. At Y location you are going to get B into AB bar whole bar, right? Guys, if you want you can solve again. X equal to A into AB bar whole bar. Try to solve this one. If you are able to solve this, you will get like I will try to write distribute over here A plus A bar plus B bar, B bar, right? Try to solve inner side. So complement is as usual. A into A bar is 0, A into A bar is 0 plus A into B bar, right? This entire terminology is 0. So you are going to get again AB bar, A is separate and B bar whole bar, B bar whole bar, right? This is the expression you are going to get. And what about the expression for Y equal to B into AB bar whole bar, whole bar? If you are able to solve this one, again you are going to get the same procedure, right? See, in terms of B they got as, in terms of A they got as B, right? If you try to solve this one, again you are going to get B into A bar whole bar, right? So if you are going to elaborately solve, so complement if you remove, that is B complement plus A. This is what? A complement plus B. So this X expression is indirectly I am saying that A complement plus B. This Y expression I am saying that this is B complement plus B complement plus A. Finally, you have an expression called Z expression. What is the Z expression again? It is trying to perform multiplication A complement B, B complement A for this whole complement. That is NAND gate, right? A into B whole complement, right? If you try to do this again, like do the transitive property, you will get. So A bar B bar plus A bar plus BB bar plus AB plus AB, right? If you observe this, these two are will be 0. So complement of A bar B bar plus AB, right? So for this, what you can do? So right, you know, right? So XR is complement of XNOR, XNOR is complement of XR. Am I right? So or else if you try to solve this expression once again, you are going to get A bar B plus B bar A, which is equivalent to XOR. So this entire, so in order to construct XOR gate in terms of NAND gate, how many NAND gates are required? 4 NAND gates are required. 4 NAND gates are required. Okay. Fine. Next one, XNOR is there, right? XNOR is what, ma? XNOR means if I have XOR gate, for this XOR gate, if you are going to add NOT gate, can we able to get XNOR? Yes, right? So simply I can say XOR plus NOT gate. XOR NOT gate, right? So you can simply draw this one. So for this NAND gate, if you are going to add one more NOT means what? Again NAND gate. So I'll try to draw the structure the same as usual. A B. Mm, there may be little bit variation in the diagram representation, but the outcome is same. Okay, this is what I will call it as XOR. For this XOR, if I am going to add one more complement, I am going to get XNOR. So final result will be A XNOR B. That's it, right? So in order to represent XNOR, how many NAND gates are required? 5 NAND gates are required. Okay, fine. Guys, if you are able to observe here, I have constructed NOT gate with NAND, AND gate with NAND, OR gate with NAND, XOR with NAND, and XNOR also with NAND gate only, single NAND gate only, right? That's the reason this NAND gate I will call it as universal gate, one of the universal gate, right? Meaning that with the help of this gate, I can able to construct any kind of a basic gate. That's why we call it as universal gate.